I hope everybody is doing better and safe despite of the busyness and the hectic schedules that we are facing for the past few weeks. This has been Alminaza Elisame Gurulyu, your teacher for today. Thank you for allowing me to discuss to you about the basic properties of fluids, specifically the fluid units and dimensions. So to start with, I have here the intended learning outcomes that at the end of the discussions, you will be able to explain the importance of fluid mechanics, its units and dimensions, and also to be able to differentiate the different units and dimensions of fluid mechanics. But before that, let us first define fluid mechanics. So, as we all know that the word fluid here does not only ends with liquids, but also it also refers to both liquids and gases, both in rest and in motions. So it has a lot on a wide range of applications in terms of astrophysics, chemical engineering, biological systems, and mechanical engineering. So meaning, fluid mechanics has been a vital role in terms of our daily life activities, which we sometimes knowingly and unknowingly used. So we have here the dimensions of fluid. So dimension in fluid is defined as the measure of a physical variable. In fluid mechanics, there are four primary dimensions such as the mass, length, time, and temperature. These primary dimensions are defined as independent dimensions from which all other dimensions can be obtained. So we have here an example, which is A stands for surface area, where area is equals to length times width, whereas the length and width both belongs to the length in the primary dimensions. Therefore, surface area A is equals to length to the power of 2 because there were two lengths. Second is velocity. So since velocity is equals to length over time, where length is length and time is on time, therefore velocity is equals to length time raised to the power of negative 1. Why is it that the time here is negative? It's because the time here is our denominator, which any elements in the or any dimensions that is being placed below is negative. We also have here the secondary dimensions, the area, velocity, volume, and accelerations, and more. However, these secondary dimensions were the most used dimensions. So, if we have the dimensions, we also have the unit of fluid. What is the unit fluid? So, human as we are, it is always important for us to have our last name or surname. So, just like fluid mechanics, it also important to have a unit in fluid. And that would be the basis on the measurements of that particular fluid or gases. So, just like any other kind of or quantity that can be expressed as a multiple of the unit of measurement. For example, a length is a physical quantity. And in order to have the measurement of that length, we need unit. So, there are different systems of units. And these are, first is the MKS system, which M stands for metric system, meter, K for gram, and S for second. Next is International System of Units or SI, which has been abbreviated from the French System International D Unites. And the third one is the CGS system, which stands for centimeter for length, gram for mass, and second for the unit of time. And last but not the least, FPS system, which F stands for foot, P for pound, and S for second systems. So if you're wondering why in the different systems of units there were only three primary dimensions and the temperature is not included, it's because temperature is absolute and anything which cannot be measured or identified. So we have here the most used units of CGS, NKS, FPS, and SI systems. So if you're going to observe here, the four systems of units in terms of the different dimensions here, they vary. However, there were some dimensions that there were two or three systems of units that has the same. However, they all uh they all have the same uh dimensions in terms of time because they used second, 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 and second. So we also have here the unit prefixes in International System of Units. So we have here the factor, the prefix, and symbol. So the factor here is something that we will written in a particular equation. For example, 10 raised to the power of 9 is a prefix for giga, which has a symbol of G. Then 10 raised to the power of 6 is mega, which being symbolized by capital M. 10 raised to the power of 3 is kilo, which being symbolized by small k. 10 raised to the power of negative 2 is centi, which being symbolized by small letter c, and so on and so forth. Meaning these prefixes is being used afterwards if we're going to apply in the particular problem. For example, gigameter, gigawatts, kilowatts, centimeter, centipois, millimeter, just like that. We also have here the quantity dimension in International System of Units. So among the four systems of units, we are using the International System of Units because it is the most common and the most applicable one. Whereas, if you have noticed here, uh, that it has a specific equivalent. So on my next video, we're going to show you, I will be showing you this exact and step by step process on how to have the dimensions as well as on how to determine that particular unit on that particular dimensions.